Hello class, so the objectives for today, we talked about momentum in the last video, which was a guest, and in this video it's more how to solve, so know how to solve momentum and impulse problems. Some of the equations used, we are going to be using the basic momentum equation, which is P equals M times V, where V is velocity, M is mass, and P is the momentum. Also we're going to do J, this is just impulse. And this would be the force times the change in time. So essentially how long is that force applied? This is also equal to the mass times the change in the velocity. So either of these equations could work depending on the problem. So let's get down to it. Alright, so this is the question. So try using some of the equations you know to figure out A. If the time is 0.25 seconds, what is the force? Alright, so now that you've attempted that on your own, you'll definitely want two types of questions. So one, we can figure out, well, what we need to figure out is what the momentum is. So we know the momentum is the mass, which would be 0.06 kilograms, so I moved my decimal place over 3 times. And the velocity is 4.8 meters per second. So it was moving this, so now it will now be stopped. So quick do the math, should give you 0.288. This would be in kilograms meters per second. And so we know at the end of it that the change of momentum will be, it started this and then eventually it ended up being 0 because it stopped, so it had no velocity. So we know that our impulse is actually going to be exactly the same as our total momentum because it will then go to 0 after. Then we can use our J, or momentum, is equal to the force times the change in time. We know that our J is 0.288. We don't know our force, that's what we're trying to find, and we know that the delta T is 0.25 seconds. Divide by this on both sides, and your force would equal 1.152. Remember, it's force, so it would be newtons. And then part B of this question is, so if the maximum force the egg can withstand is 6.5 newtons, what is the minimum time to save the egg? Remember from our last problem, we know that the impulse is 0.288. And with this formula, we know that the more time we have, the lower the force, and inversely, the more force we have, the less time it'll take. So this is our total force we can have before any harder, and it will crack the egg. So we already know that it has to stop from going 4.8 meters per second, and it's by stopping it is now going 0. And we know what our force is, so now we can solve for time. So we can plug in 0.288 for this, and then our force is 6.5 newtons, and we are trying to find out what our time is total. Divide by 6.5 newtons on both sides, and you'll get, at minimum, we need 0.044 thousandths of a second. So we don't need a whole lot of time, but you do need a little give in that catch. Alright, hopefully this was helpful. So tomorrow's problem will be a problem very, very similar to this.